You finally cave and upgrade your internet plan to a full gigabit. You expect the buffering to stop, but your important video calls are still dropping in the guest room. Paying an internet service provider for faster data doesn't automatically fix your home network. It is like putting a massive engine in a sports car that has flat tires. Those gigabit speeds have no problem traveling miles down the street and reaching the side of your house. They arrive at your modem fully intact. But the moment that data has to leave the router and travel through the air inside your home, the speeds plummet. This quadrant chart illustrates exactly why. The x-axis is distance from the router, and the y-axis is density of physical obstacles. A standard Wi-Fi wave struggles to pass through common materials. A sheet of drywall weakens it, but a brick fireplace stops it completely. When you encounter a room where the signal drops out entirely, you've found a dead zone. This is not an issue with your provider. It is the specific physical area in your house where the radio waves have simply lost the strength to carry data. To restore that signal, you have 4 physical infrastructure options: repositioning your current router, plugging in Wi-Fi extenders, upgrading to a multi-node mesh system, or installing MoCA adapters. Choosing the right option comes down to a specific calculation. You have to weigh the upfront friction of installation against how much permanent network performance you are willing to lose. The first solution costs nothing. It requires moving your primary router out of the corner office or the basement and placing it directly in the center of your home, at least 5 feet off the ground. Raising the router gets it above dense furniture, which significantly improves line-of-sight signal propagation. The trade-off is that you have to run long Ethernet and coaxial cables along your baseboards to reach that central spot, which usually ruins the aesthetics of a living room or hallway. If you want to avoid running cables, the next cheapest option is a plug-in Wi-Fi extender, but these devices are a financial trap. To understand why, look at how an extender processes data. An extender relies on a single radio. It has to catch the signal from your router, stop, and then transmit that same signal to your phone. Because it cannot talk and listen at the same time, it permanently cuts your network speed in half. Extenders also force you to create a separate network name, like home_network_ext. Your devices won't seamlessly hand off between the router and the extender as you walk through the house. Your phone will stubbornly cling to a weak signal until it disconnects. An extender functions as a temporary bandage. It technically pushes a signal further, but it actively degrades the overall quality and speed of your home network to do it. To solve that clunky handoff problem, the industry moved to mesh Wi-Fi systems. These are now the mainstream standard for whole home coverage. Instead of a router and a separate extender, a mesh system requires placing multiple identical nodes about 30 to 40 feet apart. They work together to broadcast a single, unified Wi-Fi network across your entire property. But this bar chart reveals the hidden cost of a mesh system. Notice how the speed degrades across the setup. When a node communicates with the main router using a wireless backhaul, every hop through a wall adds over 13 milliseconds of latency. By the time that data reaches a second node, your peak speed has dropped to 25% of what you pay your ISP for. The only way to mitigate those massive speed drops is to buy a tri-band mesh system. These dedicate an entire third radio band specifically for the nodes to talk to each other. Because of the extra hardware, tri-band systems routinely cost well over $300. Mesh systems provide a seamless experience as you roam around the house, but because they rely on a purely wireless backhaul, they will always inherently sacrifice peak performance over long distances. There is a way to get hardwired performance in distant rooms without drilling holes for Ethernet cables. It is called MoCA, or the Multimedia over Coax Alliance. MoCA technology utilizes the existing coaxial cable TV wiring already hidden inside the walls of most homes. It repurposes those copper lines to create a dedicated physical wired backhaul for your internet. Going back to our speed degradation chart, look at the difference when we add MoCA. Because the data is traveling over copper wire, it bypasses drywall and appliance interference entirely. It delivers near Ethernet speeds of 2.5 gigabits per second and sub-5 millisecond latency directly to your computer or a mesh node. To set this up, you need specific hardware to convert a standard coaxial outlet into a usable Ethernet port. You will need a MoCA Ethernet adapter, the appropriate coaxial cables, and a compatible splitter. The trade-off is the installation process. You must have active coax wall outlets in the rooms you want to connect. You may also need to spend 10 minutes doing some basic DIY troubleshooting at the outside utility box to ensure the coax lines are physically connected to each other. If you are doing latency-sensitive tasks like competitive gaming or 4K video editing, a MoCA wired backhaul entirely outclasses the performance of any wireless mesh system on the market. If you've looked at routers recently, you have seen the marketing for Wi-Fi 7. It is the newest, most expensive wireless standard available, heavily promoted for its 40 gigabit per second theoretical speeds. The standout feature of Wi-Fi 7 is multi-link operation, or MLO. This allows compatible devices to aggregate multiple frequency bands simultaneously, which lowers latency and clears up network congestion. But the physical reality remains unchanged. Spending over $1,000 on a Wi-Fi 7 router does not give radio waves the ability to penetrate a brick wall or dense flooring any better than a cheap router for 5 years ago. If your home's physical network foundation is flawed, upgrading to a bleeding-edge wireless standard is an expensive distraction. It will only deliver a faster signal to the same physical roadblocks. This flowchart, the network blueprint, simplifies exactly what you need to buy based on your physical flow plan. We start in the center by asking a single question: do you have coax outlets in your walls? If the answer is no, and you live in an apartment or a single-story home under 2,000 square feet, keep it simple. The only required investment is a single, centrally placed Wi-Fi 6 router. If you do have coax in the walls, and you rent or want maximum performance for gaming, follow the Yes branch. Purchase a pair of MoCA adapters. You will achieve hardwired speeds without having to ask a landlord for permission to drill holes. Finally, if you have a sprawling multi-story home and no coax wiring, follow the bottom path. You need to invest in a tri-band mesh system to brute force a strong wireless signal across that much square footage. Before you pay your provider for a faster data plan, you have to fix the physical pipes inside your house. Hardwire what you can, mesh what you must, and you will permanently eliminate the dead zones.